This is Ms. Martinez, and in this video we are looking at solving systems graphically. So let's get started. As a student, you'll be able to solve systems of linear equations by graphing and classify a system of linear equations based on the number of solutions that it has. So by the end of this chapter, you want to say that you can do this, and you could even teach this to someone else. You could explain it to someone else. That's your goal. So let's talk about how this is done. First, we have to recall that when we graph a line, what do all the points on the line represent? Well, let's take, for example, this line here. It is the line y equals x plus 3. Its y-intercept is 3, the b value, and its slope is 1. It's up 1, over 1, rise 1, run 1. So let's select just any point on this line. I'm choosing the point 1, 4. And we're going to determine what does that point mean in relation to our equation. When you substitute in those values, that x is 1 and y is 4, into your equation, it makes a true statement. If we picked any point on this line, any random point, any various point, they didn't even necessarily need to be integer values, but if you picked any one of the infinite number of points that create this line, they make the statement true. So these are coordinates. Each of these points represent coordinates, x, y values, that make our equation true. Now we're going to go a step further. When you're working with systems of equations, all they are, a system has multiple parts. So what they're going to consist of are several equations containing 2 or potentially more variables, depending on what level of math you're working with. This year we're going to work with just systems primarily of 2 variables. Their solutions are where both equations in the system are true. So the solution to a system makes both equations true. It's not enough for just one to be true. It has to be both. Both equations are true. That point is going to be the solution. This is an example of what a system of equations could look like. We have 2 equations that are representing a system. This is not a system of equations. This, we studied in our last unit, this is called a piecewise function. It looks quite a bit different. This is just one function that is restricted over different domains. Systems of equations are 2 separate equations. I hope that helps to define it thoroughly for you. Now we're going to solve our system, and we're going to do so through graphing. In order to solve our system graphically, you just need to begin by graphing each equation separately. Our first equation, which is x plus 2y equals 4, I'm going to put it in slope-intercept form. So we'll subtract the x from each side and then divide each term by 2, which gives us y equals negative 1/2 x plus 2. We'll begin by plotting our y-intercept at 2 and then plotting another point down 1 over 2. And our line goes through those 2 points. Now let's graph our second equation in the system. It's 2x minus y equals 3. When you subtract the 2x, that's negative y equals negative 2x plus 3. And we're not done because y is negative. We'll then change every sign because we're multiplying essentially by a negative 1. And that'll give us a positive y equals 2x minus 3. We'll plot our y-intercept at negative 3 and plot another point up 2 over 1. And our line will go through those 2 points. Now, the solution to the system, the answer to this system, is the point where the 2 lines intersect, where they both agree. It's the point that makes both of them true, or that is on both of our lines. The point that is on both of our lines is the point 2, 1. And that is the only point that they have in common. That is our solution that we found graphically. Let's do another one like it. Graphing each equation, you would have that y is equal to negative 2x. Notice that there's no plus a constant. That means that our y-intercept is at 0, and we're going to go down 2 over 1. That'll allow us to sketch out our line. And then we'll graph the second equation. Our second equation is 3x plus 2y, and it equals 2. We'll subtract 3x from each side, and then divide every term by 2. Our y-intercept is 1, and we'll move down 3 over 1. I'm sorry, down 3 over 2. Down 3 over 2 and plot another point, and then we'll be able to sketch out that line. Now the point that they have in common, the point where they both are true, is going to be the point negative 2, 4. Negative 2, 4. And as you might be seeing, it can be a little tricky to find solutions graphically. It is a very good way, but in future lessons we are going to look at different approaches because sometimes you cannot find it graphically. And we're gonna look at those in our next lesson. But until then, I want to wrap it up by talking about the different types of systems. This is really important. We have to be able to describe our systems. And so let's get started, kind of falling into 3 different categories. A system is considered independent and consistent if there is one solution. It's independent and consistent if there is one solution. That's going to occur when your lines intersect, because lines can only intersect, 2 distinct lines can only intersect at one point. And if we were to compare their slopes are going to be different. That's a sure way to know that your system will be independent and consistent. Independent because the 2 lines are independent, and consistent because they agree, they meet. A system could be dependent and consistent if you have an infinite number of solutions. That happens when your 2 equations are actually one and the same. It's called dependent because the lines are really the same line and consistent because there are solutions. They do agree. And you'll know that they are dependent and consistent if written in slope-intercept form, because the slopes will be the same and the y-intercepts will be the same. The last type of system is an inconsistent system, and there will be no solutions in this type of system. This happens, the only time this happens is when your lines are parallel. When your slopes are the same for your two lines, but your y-intercepts are different. These are the types of systems describing how many solutions they have and if your lines are independent or dependent. So that is all that I have for you. If you had any questions while watching this video, please write them down and we will discuss them together. Thanks.